Shiromoni has left the meeting. MIETE has left the meeting. Maybe I repeat that for the from the system might have been removed, right? But I will ask them to rejoin. It's a system actually when it starts recording, the system may remove some of the persons. So those who have been removed, I will ask them to rejoin. Okay. Anyway, so today we will start the deletion function. We'll be completing the linked list, implementation of linked list. We will start discussing the deletion, the code for the deletion from a single list. So let me start presenting. Mechanically, from we have reached to an intermediate position. Just a minute. Just a minute. The screen is visible to all of you?
Yes, sir. Visible.
Yes, sir.
Yes, sir.
Yeah.
Good afternoon, sir.
Good afternoon. So, all the functions what we discussed in the earlier class, the last class, complete list in backward manner, it's clear to all of that particular position. But what is the disadvantage? Added position is discussed, no? Yeah, definitely I discussed, I think. It's discussed, no? Added position function.
Yes, sir.
So del note function. What del note function will do? It will
Yes, sir.
delete a particular node. How the node will be selected? The node will be selected by its information. As you know that each and every node has two components. One is the information part, means data part, and another is the next part. So if you go through the main, how we are calling the delete function, you will come to know. Here I have sent a message to the user that enter info to delete the node. And that information part I have taken to the x variable. This x variable has been reused many times, right? I didn't take any new variable. Okay. I'm reusing that x variable. X variable has been used to take the information, and the node containing that information will be deleted. So I'm giving the full liberty to the user that which information, which node, according to the information specified by the user, should be deleted. Right? It may be the first node, it may be any intermediate node, or it may be the last node. Program doesn't know about this. Right? It will first find that particular node having that information, and once it will get that node, it will delete the node from the list, maintaining the remaining part of the linked list unchanged or intact. Okay. Then I am displaying the list again. So here I am sending, since it may be the first node. Okay. So I have the node I am going to delete. If the node I am going to delete becomes the first node, then the content of the root will be changed, because root is holding the address of the first node. If I delete the first node, which is if the program deletes the first node, then definitely the second node will be our first node after the node being deleted. So the content of the root will be changed. So I have to send the address of root here. Okay. So I have to consider all the possibilities. Your function, this function should be generic one, not a specific one. You may get a specific question, right? Delete the first node, right? Delete the node from the third position, or delete the last node, right? But if you understand this function, you will be able to delete from any node, delete any node in the list, right? So that's why I have written a generic function. So try to understand carefully. So here, once we are passing the address of root, like create function, right? So R, which will be the pointer of node structure, R will be a variable I have declared. R is catching the content, which is an address of the root, and since the address consecutively address holds the address of the first node, so R will be the pointer to pointer. This all we have discussed earlier. So R will be the pointer to pointer. That's why I have declared this by NDPTR star. And the information part which we have passed through X, that information part will be caught by this info variable, right? This argument. Now I have taken some necessary variables of NDPTR type to for this function. Right? Since I told you while traversing the list here, display means while traversing the list here also means in create function we are supposed to traverse the up to the end of the list. We took a temporary variable t, because you know that you cannot change the content of root at any cost. If you do so, the entire list will be lost. So always you have to take a third variable, take a different variable which will copy the address of root, which will copy the content of root, right? Star R means root, T is also root. Here also we have to reach to that particular node to delete where the information will match, right? We have to find the particular, we have to search the particular node. To search, we have to traverse the list. So we will not move the root. That's why we are copying the value of root, which will be getting from star R. Star R means value at address, R means root. We are copying that content to another variable t, and we are searching with the help of t. We are searching the particular node. We are traversing the entire list to search that particular node with the help of this t. Now while t means, you know, while t means what? T equal to t not equal to null, isn't it? Hence while t not equal to Now, you can also write this statement. So, if the list exists, it will be not equal to now, it will be true, isn't it? Let me open that file also once again. Why I am telling you uh, completely, because some of you have joined later. Okay. So it will be a revision for them also. So here, uh, delete function must be is there or not. Let me check it. I think it's US function data equal. Yeah, delete function is delete function. Okay. So it may be any node we are deleting now. Why t means t not equal to null for this example. T means the head or root. T star r means root. T star r means t is root. So if the list exists, so definitely t will not be equal to null. T will have some value. T will have the value of root, right? So here it's true. Okay, for the first time, for the first node. Now we are checking whether the value of the right now t holds the address of the first node, right? Because t star r. Now whether the node we are going to delete is the first node or any other node, that we'll check later. But before that, we are checking whether the node whether the t is reached to that particular node where the information part will match with the data part of the t, right? Means if it is true, then only you can say that we have found the node, isn't it? Because at any position, first time t is here, then if the data is not found, t will move here. If the data is not found, if it is not a target node, data t will move here. So at any position, if the program is able to find that particular target node, so t arrow data, a t arrow data will be equal to the info which we sent, isn't it? It will be true when we will hit that particular node. It is, if it will be true, then we can understand that we have reached to that particular node. We will be deleting. Now, whether whether the node we have found the data for the info form is the first node or any other node. How to understand it? If it is a first node, then t will be equal to star r. If it becomes our target node, if the data of the first node matches with the info part which we sent, becomes the first node, then definitely at this position t is star r. So we can check it from this checking if whether the t becomes equal to star r or not. If it becomes true, then you can claim that the node to be deleted is the first node. That's why we are checking this. Means after we get the match, we have to check whether the node to be deleted is the first node or any other node. If it is first node, then with this condition only, we can check it whether this node is first node or not. Isn't it? Are you understanding? Hello?
Yes, sir.
Yeah. So if it is the first node, then what to do? Whenever we will delete a node, we will store the node in and another independent variable what we have taken to make the node free from memory physically. Okay, this is the this variable will be we have taken for that purpose. Okay, so after that what we are doing, if we are going to delete the first node, now the second node will be our first node. So what, how we will do that? Now it is star r, so now it will be a star r. How to do that? Star r will be equal to star r arrow next. Let's say it is a 100, this address. If it is 200 and star r holds the 100, now star r will hold the 200. How will you get the 200? From here. So star, if I write the star r assigns to star r arrow next, so star r becomes 200, overriding the 100 which was previously there, isn't it? So star r will be star arrow next. That is exactly what we have done. Star r is star arrow next. Now the second node will be the first node, right? When the base address of the second node will be stored in our root node, root star. If not means if the node to be deleted is not the first node, then any other node may be the node to be deleted, the target node. So else part will be executed for this if it becomes false, right? Means we have already moved t is somewhere else, not at the first position. So else part will be executed. So again we are what we are doing, we are storing the value of t in any another variable temp, like what we did here to make it free. Now here, every time when we are moving the t, every time when we are moving the t, what we are doing, we are holding the base address of that base address of the previous node of that node in another variable prev. Let's say if the t is here, then prev is null. When t will move here, prev will come here, right? When t moves here, prev will hold the value of this. This prev is another independent variable which is holding the base address of its previous node, right? Why it is necessary? Because let's say it is our target node. It is our target node. So temp, if the temp is here, if t is here, so and we should store the value of its previous the address of previous node somewhere else, that is with the help of prev, right? Because we have to do this one to delete this node. What we have done this here, arrow, this is not shown clearly here. Prev, if it is prev arrow next will be what? T arrow next. Because now the this next will not hold the address of this. Next will not hold t. Rather, next will hold this one. How to get the base address of this node? From this variable. And how to access from this value? How to access this value? T arrow next. So here we are assigning the value. How we are getting this one? Prev arrow data, prev arrow next. From prev arrow next will be assigned to what value? This value. How to get this value? From this. This is our t. How to access? T arrow next. So prev arrow next will be our t arrow next. If we do that, then this link will be established, cutting this and this. This connection will be cut off, right? So exactly that we have done here. Prev arrow next is t arrow next, right? And prev we have taken earlier. Prev is another temporary independent variable because it is holding the value of a base address of a node. That's why it must be independent type of variable. Now after we delete the first node or any other node, we have to make the memory space free for the use of any other application, right? We cannot engage that memory space. So it is a convention that the good program always makes the space free which has been allocated dynamically. So free is a function, it's not our function. Free is a library function which makes a makes an address free, makes a storage location free, which has been allocated dynamically. So free function does this one. So now whatever the node we have made free, we stored it in temp, right? And back here on that temp. So here we are making that temp free from the memory using this free function. Okay. And once we delete, once we are able to delete the node, our purpose is served. So we don't need to move again. We don't need to continue the loop anymore. So we will return it. Like say exit here, not exit, rather will exit the control from the loop and continue with the remaining part of the function. But here we are not doing that one. We will be skipping this remaining part. So we will just straight away return the control from the function to the place where the function was called from. We called the function from the main function. So control will be returned here. Okay. Now let's say we are going to delete this third node, this node. Let's see. Means here we have got the data. Okay. Then what we have to do? The means third node. How? T. So T is star R means T is the first node, right? Net it's true. T not equal to null. It's true. Now, if T arrow in data is info, isn't it? We are checking the data part, right? No, it's not. It's false because here, let's say, assuming that data is here, the data is the node containing the data will be a third node. If we assume that one, then it will be false. T arrow data will not be info, so it is false. It is false. So this if construct will not be valid, then else part will come. Means control will enter else part. Since we are not getting the node, we have to move for the other node to search it. Okay. So before we move on, what we did, we have to assign its address in some another location, that is prev. Means before we move the T from here to here, we are assigning its address to another independent variable, that is prev. Why I have given the name prev? Prev stands for previous. So prev will hold the address of the previous node before we move the T from the location to the other location, the next location, right? After that, after we assign the prev, what do? We are moving the T. So now T will be equal to T arrow next. Means conceptually T comes here. We are moving the T. T is T arrow next. So before we move, we are storing this value of the T to another independent variable, right? Now again, it will come to the loop. It will check again, because while T not equal to null, T comes here, T comes here, right? So T not equal to null, T has it as an address. So it's true. It's true. Now we're checking if T arrow data is info. Still it is not true, because assuming that this data will be we are going to find. So T arrow data is not equal to the info part, right? So here also again the same thing will be repeated. If it is false, then again the control will come here else part. Now again we are moving t, but before we move t, what we are doing? We are assigning its previous node, the address of previous node to another variable prev. So prev is t, t is our next. For the second iteration, now t will move here, but before t before t moves here, prev will move here. Prev should come here, right? Prev was there for the first iteration, second iteration, prev will be here and t will be here. Okay. Now, now again, is t arrow next. Now t has reached to that position, assuming the third position is our target node. While t is true, right? Because t is here, t is here, t is here. Now let's see. So T arrow data. Now we got the match, right? That's fine. So but T not equal to now it's true. Now T arrow data is info. Now it becomes true. So you will what you will do? You will delete this one. To delete this one, what you will do? We are the program is doesn't know that it is the last node or any intermediate node, whatever it is. Our program will delete that node and will make it null or will make it the address of the next node of the t, right? Whatever it is, it will do so. What it is doing means it is true. It is not true because t is now not the first node. It is not equal to star r because t is now here. T is not here. T is not star r. Star r is only valid for the first node. So else part will work. Now temp is t. Temp is t means we are assigning the t to another variable temp to make the memory space free after we delete this node, right? Then what we are doing? Prev arrow next is t arrow next. Now what is t arrow next? For this picture, for this case, what is t arrow next? T arrow next is null. Right. For this picture, only three. If the three nodes are only present, and if we go to delete the third node, last node, so definitely the next part of the last node will be null, right? So t arrow next becomes null, right? That value we are assigning to the prev arrow next because prev is here at this time. So prev arrow next will become equal to t arrow next means prev arrow next becomes null. What we are doing this one. Prev arrow next is t arrow next. Means this becomes null. This becomes null. So means conceptually or physically this node is conceptually this is the last node. And to make it free physically, well, again this free temp will be doing that. Right. If we go to delete the second node, I discussed this one earlier also. So in this way, from any position, it will delete the particular node and establish the link in this way so that the entire list should maintain its sequence as it was before its deletion. Okay. And if it traverses all the nodes and let's say anybody has if an user supplies an info part which is not present in any node, so what message is expected from the program? Data is not found. So this we should put here means after, if it is true for any case, if we get the node, right, if the program is able to search the node, means if the data matches in any position, it will delete the node and return from here. Control will never reach here, right? Control will reach here when the entire list is traversed. Let's say in this case, after searching the three nodes, if data is not found, then what will happen at times while t will come here, t is tr on x, every time we are moving the t. So when we are moving the t for the last node, t will become null. T is tr on x for the last node. When t will be equal to tr on x, means t will be null. So if the when t is null, so loop will be stopped. It will not be true anymore. So it means we have traversed the entire list, but we didn't get any match because never this return statement has not been executed. This statement will only be executed when we are getting this data, right? So control will come here after the entire list is traversed, means after all the iteration is completed for this while loop, control will come here, and this means we didn't get the data, so we should print something this way, data not found. So let me execute the program, compile and run. How many nodes you want to create? 6 nodes, let's say, right? 10, 20, 30, 40, 50, 60, 10, 20, 30, 40, 50, 60. After that, our add at beginning function worked, right? Add at beginning 999, right? So it has been added to the existing list, right? 999. Now again, after that, our add at position is being worked, right? Add at position. That's why you're getting this. Enter after this. Enter the position and info for the new node to be inserted. Right. Actually, we are executing the entire program. At last, we will be executing this del node. That's our program will execute this node once we complete this one. So enter the position and info part for the new node. Right now, our status of the linked list is this. This. Enter the position and info for the new node to be inserted. Let's say the position, the first or any position, let's say it is just select any position fifth. It means 1, 2, 3, 4, fifth, this position. Let's say 35. But it 35 is inserted, right? At the fifth position. Now enter info to delete the node. Let's say I'm getting something this whatever an arbitrary value, which will not be found. So we should expect the program to display data is not found. Data not found. Then we are displaying the list actually, right? The list is intact. Before that, we are getting data not found. Okay. And we will delete. Now we will run the program to delete a node. Before display function. Let's put a window. So, how many nodes do you want to create? Let's say 6 nodes, 10, 20, 30, 40, 50, 60. Fine. This one. The position info of the new node. Let's say last position. Let me insert a node in the last position. 1, 2, 3, 4, 5, 6, 7. So eighth position, na? Let me check. 70. 70. The last question also it is getting inserted like create function. Okay. So this way you can insert and you can insert a node at any position. Now enter the info to delete the node. Let us delete a node. Let's say 30. Okay. See 30 is deleted. Right. Maintaining the list intact. Got it? Hello. Are you watching?
Yes, sir. Got
Yes, sir. Clear, sir.
Clear.
Yes,
Any
sir.
question? Any question? You should raise any question if you. I think it's. I have enough doubt that it is clear to all of you. Because actually, you can ask me the particular part, a particular segment of the code, which seems to be difficult for you to understand.
স্যার
Hmm.
প্রোগ্রামে আমাকে অ্যাড এট দ্য বিগিনিং সুইচ কেস ঢোকালে আমি চয়েস অনুযায়ী করতে পারবো।
বুঝতে পারছি না ভয়েসটা ক্লিয়ার না একটু আবার বল ভয়েসটা ক্লিয়ার কর
স্যার এই প্রোগ্রামটা এন্টায়ার প্রোগ্রাম রান হচ্ছে মানে অ্যাড এট দ্য বিগিনিং অ্যাড এট দ্য পজিশন এন্টার ইনফো করছে তারপরে ডিলিট হয়ে যাচ্ছে। তো মানে যদি আমি সুইচ কেসটা ঢোকাই মানে আন্ডারে তাহলে তো চয়েস চুজ করে তখন করতে পারবো।
কিছু বুঝতে পারলাম না রে কেন বলতো তো হচ্ছে হ্যাঁ এই, বুঝতে পারছি না কেন
স্যার এক
সায়ন্তন
মিনিট
হ্যাঁ
করে
একটু দেখ মাইকটা ঠিক কর বল
স্যার এবারে ক্লিয়ার আসছে?
হ্যাঁ হ্যাঁ হ্যাঁ
স্যার এই প্রোগ্রামটায় যেমন এন্টায়ার প্রোগ্রামটা রান হলো মানে অ্যাড এট দ্য বিগিনিং অ্যাড এট এনি পজিশন তারপরে ডিলিট হলো তো আমি এর আন্ডারে সুইচ কেস ঢুকে যে কোনো চয়েস
হ্যাঁ
করতে
হ্যাঁ 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 definitely that will be a good one for any operation when you are supposed to select an options from multiple operations if you have any scope to run a particular operation according to the selection of the user you can use switch case so very good so I will give you an assignment so Sharantan, thank you for remembering. So what you will do, you will rearrange the program. Just you will have to rearrange the main, isn't it? Rearrange the program will with the switch case, right? And you have to input this switch case in do while loop. Means after any case is executed, there should be an option left for the user to select whether he or she wants to continue with the program or not, right? Means do while, right? With do while at last it will be checked whether you want to continue with any other options or not. If not, then press N. If yes, then press Y. Got it, Shantan?
ইয়েস স্যার। স্যার আমরা তো ওয়াই মান দিয়ে ওয়ান একটা ট্রু নাম্বার তো কন্ডিশন যদি কি থাকবে?
Do while এখানে দিতে হবে কেন বলতো? Who will answer? Here only the do will loop will suit better. Why? Only for this kind of interaction, for this kind of interactive program, only the do will loop is preferred. Otherwise, we don't use do will loop much. Only for this. Sneha, why I'm to use do while? Or anyone else can answer.
তাহলে তাহলে মানে কন্ডিশন চেকের আগে ওটা একবার প্রিন্ট হয়ে যাবে মানে ডিসপ্লে দেখতে দেবে সুইচ কেস স্টপ হয়ে যাবে আর
All of you are understanding. Do while means that menu. You will be able to see the menu always. Right? Say number one, create a node. Number two, case two. Number two, press two for adding a node at beginning. Press 3 for display. Press 4 for count. Press 5 for add at any position. Press 6 for delete position. Or by default press any other key to exit from the program. Right. This way. So always that display, that menu will be there. It is the menu based program, right? Fine. So you will use do while do for this. Okay, let me tell you one thing that Manisha Bharti, Sayantan, asked her to, uh, to inform me the reason. Every time I have seen that this Manisha Bharti leaves the meeting before the class is completed. I don't know. Auna Das goes as left. So Auna Das goes is a regular, more regular. I don't know. But specifically for this Manisha Bharti, every time this she should not get the technical problem, right? So this then lame excuse. So ask her to report me for the reason why she is doing this one, right? Manisha Bharti.
Okay, sir.
Okay.
Okay.
Anyway, so have you understood the code, all of you?
Yes, sir.
Because once you will be once you have understood this one, I will implement this.
Understood, sir.
I will implement this
Understood, sir.
using some other problem to solve the other problems like implementation of stack or queue using linked list. You have done implementation of stack and queue using array and static memory allocation. Now onwards you have to do implementation of stack and queue using linked list, right? Okay. And after that we will move on to double linked list. Okay. So let us complete this today's session and I will be giving you the material. Actually, I wanted to give you the entire code as material. That's why I didn't send the intermediate part with the incomplete part of the code as a material, right? Okay, fine.
Okay, sir. Okay.
Okay, sir.
Anyways, thank you. Bye.
Thank you.
Thank you, sir.
Thank you, sir.
Uh,
Thank you, sir.